Okay, from sometime between right this moment and Friday, preferably Thursday evening, what are you guys going to do between now and Thursday night? You're going to bake pies, I hope. If anybody else wants to bake a pie for Pie Day, there's still room on the list. Reminder, if you're bringing a pie, please bring a utensil to scoop it out because I don't have 40 pie scoops. Cool. Like, I'll go wash it between and you'll get it back at the end of the day. You can even take yours with you if you want. But cool. All right. We had one problem from the assignment. Is this the last problem? Is 89 easier? What'd you guys get on 80? Oh, gross. We'll come back to 89 here in a second. Let's knock this one out. Before we do this, how many people want to work through 85? We can do a closed eye vote if you need to. Okay. No closed eye, but I get a lot of nods and stuff, so I'm cool with that. Okay, here we go. We have an object that's moving in a straight line. That's all this means, rectilinear. Okay, rectangle and linear. Cool. 2 dimensions. Motion is moving along the horizontal line with velocity over the indicated interval. We are trying to find the net displacement. Okay, and we're trying to find the total distance. Now, we can sketch this graph if you want, but I don't know that we need to. I'm trying to find the displacement, which is that gotten from velocity directly anyway? Like, what's displacement? It's a position idea, right? It's how far you are from where you started. So where we get wonky with this, the displacement's easy. Nothing weird about it. The total distance is where things get a little bit harder. But if I have this velocity function, how on earth do I get back to position? So I'm okay with the language antiderivative, but there's a new word that we've been using. The integral. Let's use the integral. So if I take the integral from where to where? Y0 to 3. Good. Because time is stuck between these values. There's our boundaries that we have. So as we're looking at it, here's our first step. Now, decision time just as a class. Do we need to talk through every part of this antiderivative? Or can I just talk it out loud and do it in one step? Okay. So rather than me just talking it out loud, we're just going to call randomly. Rafa, we made eye contact. What does this turn into when I anti-differentiate it or integrate it? 2t cubed. I agree. Plus, Isha, what does this one turn into? Indeed it do. And let's see here. K-rad, what happens to 18 when I integrate it? 18t. Fantastic. Did I miss here? Okay. So, why did I draw that line? For what? For the bounds, absolutely. And what theorem or fundamental idea am I using here? Which part of the fundamental theorem, I guess? Good call. This is part 2 of the fundamental theorem. I put these numbers here, 0 and 3. And just looking at this is number 84, right? 85. I think that this is going to be 54. Okay. So what we have just found, and I just want to really stress this. So if you guys, you're not going to see this on the video, but here I am at position 0. Okay, here I am. Now, what we just found is the displacement is a positive 54, and that's positive in your perspective. So check it out. We'll just say that, like, let's say 54 is right here. This is 54 away from the starting point. I want to just make sure that we're cool with this. If I start here and I just walk like this, what is my displacement right now? 54. What's my total distance? 54. They're the same thing right now. Everybody cool with that? So I'm going to do another trip here. Here I am. I'm at 0. And we're going to walk to 54. Then I'm going to walk all the way up to 100. And I'm going to walk back to 54. What's my displacement? Still 54, because I'm only 54 away. But is my total distance different? Because I went an additional 46 and 46 back, right? So I now have a total displacement that's way bigger, or sorry, a total distance that's way bigger than my displacement. Okay, so as we think about that, the cool thing is we don't have to account for that here. 54, if this is how I answer this question, am I going to get points? Why? So what should the context be? We're going to try it here. I don't know if this is going to work. The what? I don't even know where it's writing. What? Hold on, something weird happened. Give me just a second. Let's try this. The. Okay, that's so small. I don't know. What size font do we need? 48? We'll try it. The. Eventually. You know, it would have been faster to write it. The what? Is displaced. Ooh, we're going to see if this works. How far? In the positive. You're okay with right, but I would say in the positive direction. After how long? 3 minutes. Boom. Look at that. Fantastic. I'm going to start typing these more and more because that's way faster than writing it. Sorry that you guys can't type them. Cool. Well, what's the difference between this and finding total distance? How do we find the total distance? That's kind of rhetorical. Check it out. Same question, but instead of just awkwardly waiting in silence for one person to answer, how do we take this, which is just our displacement, and get our total distance? 60 seconds. I'm going to call someone random. Chat with each other. Come up with ideas. Don't care if they're good or bad. Just ideas. How can we possibly find it? Make sure we can do some algebra. I'm not going to make you graph this function unless you really are dying to graph a quadratic. If you want to, we can, but I think that we are just as well suited if we simply let Desmos graph it and think about this. Anybody want to graph a parabola right now? Okay, so I need somebody to read me the velocity function that we just had. Okay, so here it is. Now, we only care about which time range? 0 to 3. So here is what my graph actually looks like. And for this, it's a terrible scale, but we're just going to pull it back up here. Okay, when I initially start, what is the sign of my velocity? It's negative. Now it's getting bigger, so we're accelerating positively, but it is negative, which means if I'm standing here, which way do I start walking first? If I have to go in a negative direction. Because that's what the velocity says. I start negative until I get to that point. So which way do I walk? So I walk left however far, and then I get to whatever time this is, and I'm trying not to hover over it. And I just did. And then we walk back for the rest of the trip, right? Okay. Once we see this, and it's really nice to look at the graph for now and tie back to these things, we need to decide without just having Desmos graph this, and preferably without us graphing it, how we could find where this function is positive and negative. But check this out. Algebra 2 shows back up. When does a function change from being positive to negative? At its x-intercept, or the roots, I heard somebody else say. So we're going to take this problem, and we're going to do it without the calculators, just good algebra practice. Let's find, on B for this, we're going to find a couple things. And I want to start off by finding, on B, let's find where V is positive and negative. So I'll write that down as like a pink part so that it's up to you if you want to write it. But we need to know when, and I'm going to be short in this, V of t is greater than 0 and when V of t is less than 0. Which in hindsight I could have just said where the roots are, but that's okay. Do you guys hear the loud hum? I don't know what it is. It's been going on and off over the last several days. I don't think it's out there. I think it's up here. We can try to close the door. I'm going to try to ignore it. Sorry, I pointed out for everybody. Where do you guys think it's coming from? You think it's a projector? Yep, I think it's something up in a fan in the ceiling is what I think it is. Okay, anyway, here we are. We have this lovely function, and I need to solve this and set it equal to 0. So here's V of t. Why am I setting it equal to 0? Not because it starts at 0, but that's a good thought. This is when my velocity is 0, not at time 0. Why would I care about when the velocity is 0? About 5 times louder, I think there, Aisha, because I'm pretty sure I read the lips correctly. To find the root. So let's do that. Find me the roots of this. Use your F word. That's factor, by the way. Factor this. I'm going to give you guys a second. Without your calculators, just throwing it out there. Factor that. 48. I'm also going to start factoring. If you didn't do the GCF first, it's not done for, but you have much bigger numbers. Before we kick forward from here, questions about the factoring? Anybody get goofed up with it? We have not been doing daily factoring this year. Cool. All right. So we're going to keep kicking back to this idea because the calculators are awesome, but maybe we won't always have them. Like, in fact, half the test you don't get calculators. So what do I do with these? If I'm really just trying to solve an inequality, where could I put these? I think we've done it over and over and over this year. Let's put these on a number line. Just like we did with critical numbers and possible points of inflection, we're just going to see when is our velocity function positive and when's it negative. Now, one of these roots is absolute garbage for this problem. Which one and why? Why would negative 3 be garbage? Yeah, time doesn't go backward for this, and maybe ever, but that's a bigger question. Okay, so check it out. I only have one number to put on my number line, and normally we use arrows for number lines. I'm not going to here. Why? Why is this not the right number line to use? Yeah, the bounds. What's the only times we care about? From where to where? So let's do that. Here's 0 and 3, and I'm going to label this as velocity at time t, and there's only one root for velocity. At 1. So notice the lack of caring about my scale. There's my 1. Well, I already know what happens because of the graph, but we're going to hit some old ideas. Would you rather plug in a number between 0 and 1 or a number between 1 and 3 into this? If you say 0 to 1, I'm going to make you do it. Because you're going to have to do 6 times 1/2 squared, and like, I don't really want to do that. Could I use 2? Okay, notice. Do we put any more dashes on our number line? No, this is the only dash. These are just the endpoints. This is our root. So when I plug in a 2, and I'm going to look at this one or this one. Realistically, I'm going to look at that one because it's easier to plug into. If I plug in a 2, this becomes a positive number times a what sort of number here? Positive, and it's 5, and I saw somebody, like, I saw that number show up. And this one, if I put in a 2, positive. What's a positive times a positive times a positive? Positive. Okay. I'm going to make a claim here that I don't need to check 1/2 or 1/3 or anything in here. How do I know, without doing any additional work, that it's a negative right there? I heard somebody say the word. I don't know where it came from. Yeah, I don't know who said it. Good job, whoever said it. Multiplicity. This root showed up how many times? And is that an odd number or an even number? If it shows up an odd number of times, the sign changes. Awesome. Why do I care? Like, does this, first of all, agree with the graph? Did we see that the graph was negative between 0 and 1? Why would I care about this? We now have a way to split the integral. Now, the picture does not, or the graph doesn't have to be perfect, but if we want a way to think about it, here's what my graph is doing with a nicer scale. That's at 1. Okay, and that's at 3, we'll say. If I took the integral, this is all the wrong sign for the integral for total distance, right? Because that's going to give me the negative, and that's why my displacement works out. If I wanted to work this out, how can we split up this integral so that it guarantees that I get only positives? And I'm gonna let you guys try this, but I'm gonna write this out first. We started with the integral from 0 to 3 v of t, right? how can we split this up to ensure that this winds up positive, this little region down here, and that this ends up positive? Talk with your neighbors. I need you to write me an integral. I'm going to write a mistaken version here that's for total distance. And my guess is somebody probably has exactly this. Now, don't panic yet, because everybody should have started with the integral from 0 to 1. And then what's the other integral? Okay, with what I've done right now, is this going to give me total distance? Why not, Delilah? Yeah, this is my displacement. This is what we did in the first problem. We just cut it up into two. Which one of these has the wrong sign? There's two options. And actually, there's more than that. If in our notes, Delilah, what you found right away, what did it say we do with this? We do the absolute value. Now, we didn't take the absolute value of the integral of an absolute value. I'm going to be honest, that's something that I don't really remember doing a whole lot. I don't like absolute value stuff. I'd rather do this. I wish I did remember it. Anyway, how do we fix this then? There's two options. Two easy options. If I know it's going to be negative, what could I just put in front of it? A negative. Or if I know it's going to be negative, what can I do with these, the boundaries? We could just switch them. So whether I write this as the integral from 1 to 0 to ensure it comes out the right sign, or the other way, doesn't matter to me. When I actually do these, just so you know, this is really what I think. I think of the absolute value after the fact. That's the easier way in my head. Okay, anybody happen to have this number yet? It's 10 plus 64. So what's our total distance? 74. Now, as we go through these will not take as long, obviously, when we do them again. Am I going to get credit here? No, probably not. Why? I don't know if I can just move the T. Nope, scratch that. Why won't I get credit? What is the context? I'm not going to write it. You guys can just tell me. Good. The object travels 74 meters after 3 seconds. Or I would be more specific. I want to change one little thing about that. The total distance the object traveled. I would include the word total distance in there. Okay. Doable? Sweet. Well, I think that you should do some more integration today. No? Okay. What was our topic yesterday? Hey, there's a play on words locked in. It was hilarious, whatever. Okay, so I believe this is the problem that we looked at yesterday. Now, you will get better and better by picking the choice for you as we get practice with it. I assure you, it just takes practice. Right now, I'm just going to try to identify, and then we're going to go up and do some more board work here in a minute. But I think there's 3 choices for that I might use for you. I think the obvious first choice, or an obvious choice that somebody would likely take, is this. And this, I think I asked you guys to do this yesterday, and I told you to do this rather. Now, for this, I want to clear up one little thing, because depending on the book, depending on the resource, you're going to see this 2 different ways. If this is u, what was the next step of our u substitution to integrate? We find du dx. Okay, so if I find du dx, what is it? 3x squared. Now, there's no 3x squared to plug in up here, which is kind of a bummer. What we did yesterday was we went from this, and then we said du equals 3x squared dx. Almost identical. I think it was 2x that we did. But I just want to make sure, and we'll see this today, another technique. If you don't like just solving it for du, could we just solve it for dx? Like, can I rearrange this and get dx? And what would that give me? Dx is equal to what? Du over 3x squared. Now, when I actually do the integration, this feels more natural because I don't have to try to find all the pieces. I would just take this and replace it straight with that. Now, I'm going to physically write it. You guys don't need to. If you don't realize that integration fails at this point, you're going to keep working. So let's just make sure we can all see what this looks like when it fails. I would now have x cubed. Just kidding. I wouldn't write x cubed. What would I write there? U. And then e to the x to the 4th. And then if we're doing that other thing that I just mentioned, where instead of replacing du with the stuff and I just solve it for dx instead, this would be du over 3x squared. Why does this not work? Ooh. Talk it out with your neighbors instead of like just awkward silence. Why doesn't this work? Okay. The fact that there's anything other than use says, nah, doesn't work. But notice, it's okay to fail. You're going to fail. If I don't get only use, it doesn't work. Like that's the goal. We need one single variable here. Okay. So if 3x or x cubed didn't work, what's another choice that somebody might make for u? So I heard e to the x to the fourth. Sure, let's try it. If we do that, what is du dx? So I'm going to put this up here just in case we need it. How do you integrate, or sorry, differentiate e to the u? E to the u times u prime. Okay, so what is this? E to the u, is that nothing changes, right? E to the x to the fourth times 4x cubed. Now, I'm going to rewrite this without this ugly times in between it. Can I multiply it by dx? Like that's what we always do. I think we can. Can I multiply by dx and divide by all this to get it just dx equals? I need you to be like completely honest with me if you don't understand what happened here. I'm going to change that order. I'm going to make that 4x cubed times e to the x to the fourth. Did anybody not catch what happens? Okay, is this integral going to work? Well, let's check. Like I like that you're confident with it and that you answered. 1/12 is not bad. Let's try it. The integral of, well, let's check. X cubed is still there, but instead of e to the x to the fourth, what do we write? U. And then instead of dx, what do we write? Du over 4x cubed e to the x to the fourth. So that happened, which was pretty awesome. But is it everything awesome that I need? Why don't I like this integral still? Gosh, ux, am I right? Like u and x, that's a stupid joke, but that's okay. U's and x's mixed together, bummer. Good try, worth a shot. Well, is there another choice of u that we could try? Let's try the only thing I think that's left, x to the fourth. If we do this, what's du dx? And I'm going to do something here. What's du? And then, good. Love that change. We can save one line of work easily. Everybody can. You're just going to add dx to the other side. And then if I solve for dx, what's dx? Du over 4x cubed. So if you can tell whether it's going to work here, awesome. If you can't, awesome. Let's just plug it in and see if it works. We're going to rewrite this integral. And instead of x cubed, just kidding, we still have x cubed. So it's still there. And then e to the what power? To the u. And then du over 4x cubed. This works. And I can tell it's going to work. What falls out of this? X cubed. They divide out there. Any constant multiples that could come out of this integral. So, love the change. Did you say 4 or 1/4? Love it. 1/4 times the integral of e to the u du. Well, look at that. We now have an integral that only has one variable, and it's all this manipulation that we were doing with it. We're just rewriting it in a way that's convenient. Is that integrable? Integrate it. Do it. Do that for me. Give me the integral. I want to know the answer in the end. Cool. Okay, so looking at this, I'm going to keep the 1/4 outside for a second. And Angel, you're going to hook it up. What did you say the integral of e to the u was? Hey, love it. And what else should we tack onto this indefinite integral? Plus c. Nope, hate that. And then we're one step away. What's u? So this is 1/4. E to the x to the fourth is what we chose for u. So here it is. Plus, now I could write 1/4 c, right? But what's 1/4 of a constant? Still a constant. And we have it. Okay. It's okay. And I cannot stress this enough. It's totally okay for this to happen. It's going to keep happening for a while. It still happens to me when I do hard integrals where I try one and it doesn't get nicer, then I would just change paths. It's all right. You will start developing techniques to get better and better at choosing these. Let's do a few examples or a few problems up on the boards. Cool. So, looking at these, we're going to get some random groups really quick, and that looks like a random group generator. I need your names. So we'll do. But this is what most groups ultimately wound up choosing. You might have tried others, but this works. Now, sorry about the ugly 3. I had it as a 2, and it wasn't working for me, and I couldn't figure it out, but I had a typo. When we picked this is u, here's our du dx, and then here's when I solve it for dx, and I've already factored it because I can see what's going to happen. I have 3x plus 3 over u times du this. These pieces, are gone, which means, is there a constant multiple? So we get a 3/4, and it's now the integral of what's left inside. 3, no, the 3's not there. 1 over u. Or, this is just another way to write it, but du over u is the same thing. What's the integral of 1 over u? It's the natural log of the absolute value of u. And what was u this whole time? Okay, perfect. Anything else we need? Plus C. Okay, this evening, I want you guys to try those. Homework 5.5.1, you'll find on page 441. And I want you to try problems 21 through 39 odd. Now, I want to really stress this tonight. You should not spend more than 45 minutes on your homework. If you only have 3 problems done, but I can see that you've tried and failed like every possible combination of you, that makes sense that you wouldn't get all the problems done. 45 minutes, don't erase failure, cross it out, and try it different. Cool? All right, peace out. Hopefully we get lots of good questions tomorrow. Thank you. We missed it. Sorry. You got it first hour, right? Okay.
What do you use these for?
To write on the wall and windows. If you want to draw a picture on the window, yeah, come in at lunch. Come draw me a wonderful picture. I like the flowers that you draw. I like the flowers. Like, I'm trying to think of where else I see them. On your parking spot. Yeah, they're super cool. Some of them, yes, if you come in, I'll show you how to use them and make sure that they don't die.